So this question is about thermal expansion. So we have a copper ball and we add heat to this, so we heat it up until it becomes slightly larger. So the volume increases a little bit because its diameter increases by a little bit. We want to know the final temperature. So the change in size, the expansion, is proportional to the change in temperature. So if it was a rod, then the change in length, delta L, will be proportional to delta T. If it was a two-dimensional object, then the change in area would be proportional to the change in temperature. And in this case, we have a three-dimensional object of volume, so the change in volume will be proportional to the change in temperature. So let's write out the expression. Change in volume is proportional to change in temperature. Now, the constant of proportionality is actually 3 times the coefficient of linear expansion, alpha, or at least we approximate it to this. So this is what we'll be using as the constant of proportionality. The other factor is the original volume, the volume of the object before we expand it, before we heat it. And there's a formula for the volume of a sphere, so that shouldn't be a problem. So the question is asking us for the final temperature. So to find the final temperature, we need to know the initial temperature and the change in temperature. So let's rearrange to find the change in temperature, because this is the first thing we're going to be using. So our change in temperature will be delta V over 3 alpha V naught. Now delta V, the change in volume, is simply the final volume, that's the volume after expansion, minus the initial volume, the volume before expansion. And there's a formula we can use to find the volume of a sphere. We just need to find the radius. So the radius before expansion and the radius after expansion. So this is the radius before expansion. That's given in the question. The radius after expansion we need to find using this extension to the diameter. Now the diameter is twice the radius. So if a radius is 1.5, the diameter is twice that. So if the diameter increases by 0.19, then the radius will increase by half of that. So let's write that down. So the radius initially is 1.5 centimeters. The radius after expansion is the same, plus 0.19 over 2. Why do I divide by 2? Because the 0.19 is the change in diameter. Divide by 2 to find the change in radius. Now what I need to do is multiply times 10 to the minus 3 because I'm converting to meters, and the 0.19 is in millimeters. So that's my meters. So let me just write that as a useful number. So 1.5 times 10 to the minus 2 plus 0.19 times 10 to the minus 3 divided by 2. So that's 0.015095. Okay, so now we have our two radii. We can find the volume. So let's just remind ourselves what's the formula for the volume of a sphere. It's 4 over 3 pi r cubed. So we can find V naught by substituting R naught cubed, so that is that. So V naught is one 0.414 times 10 to the minus 5 meter cubed. And V1 is the same, but we'd use R, well, I should call it V2 really. So V2 is the same using R2 cubed, and that gives me, so that would be my R2. That will give me 1.441 times 10 to the minus 5. Now we just need to substitute these numbers in here and see if we can find the change in temperature. So the change in temperature is 1.441 minus 1.414 times 10 to the minus 5 divided by 3 times 17 times 10 to the minus 6 times 1.414 times 10 to the minus 5. So we can get rid of that. And if I put that in my calculator, that gives me 374.4. Kelvin. So that's my change in temperature. So if we want to find the final temperature, T2 equals T naught plus the change in temperature. So we can do that in Celsius or in Kelvin. So if we do it in Celsius first, because the numbers we were given in the question, temperature we were given was Celsius, we can say T2 equals 22 plus 374.4, which is 396.4 Celsius. Or we could say, and this is the better way to do it, in Kelvin, it's 22 plus 273 plus 374.4, and that's 669.4 Kelvin. So this is your final answer. To do this, we needed to know the volume of a sphere, but more importantly, we needed to use this formula for volumetric expansion, where the coefficient that we use is 3 times the coefficient for linear expansion, and the change in volume is proportional to the change in temperature, or the change in temperature is proportional to the change in volume. And we needed to also make sure we realize that the change in diameter isn't the same as the change in radius. We need to divide the change in diameter by 2 to find the change in radius. So that was important. I hope you found that helpful.